Hello, Mr. Fry's Algebra 1 class. I'm looking at the vertex form and transformations worksheet. This is the vertex formula where whatever numbers you have in here are your h and your k, and that's going to be your vertex. The h and the k is going to be the vertex. So if you can get it in that form, that would be the easiest way for you to look for the h and the k value, and that would be your vertex. Okay, let's take a look at some of these. Also, you could use Desmos, and you could plug these in to Desmos, and you can figure out some some of the points you could plot and all that kind of good stuff. Number one's actually a little bit more difficult. I'm surprised they started with this one because it doesn't really look like this, but it actually is like that, where you just have, it's kind of like if you would, like a -1, and then you just have your x squared, so there's no minus h in there, 0, and then you have and if you were to put that in parentheses, I guess you could put that in parentheses, or just -3. So this would be like your a, this is your x, minus h squared, all completed already there. So that would be 0 would be your h, and your k would be -3. So that's why the vertex is 0, -3. In fact, if you put this in Desmos, you see that the vertex is right here at 0, -3. Okay, your axis of symmetry is going to be 0. So whatever your x value is of your vertex, that's your axis of symmetry. That's the line that kind of splits it right in complete halves, if you will. The vertical line that does that, that's x, where x equals 0. The domain is always going to be all real numbers, because this will continue to go fan out and cover all of the x values. Remember, domain is the x values, and that's all real numbers. The range is going to be y is less than or equal to -3. So everything on the y-axis, starting at -3 and down and below less than, is going to be the range for this. And usually when we find the vertex, we'll put that in the center, and we grab 2 numbers before and 2 numbers after. And just plugging this in, you could plug those x values in, and you could solve for your y, or you could plug it into Desmos, and you get these y values. These 2 are off the chart, so I only have these 3 right here. All right. Don't pay attention to that. I was actually working on number 3. I want to do the odd ones for you. So for number 3, this is easy to see. They should have started with this one. Here's your h value. Here is your x value. Now remember, h is negative h. So we already have a -2. So a negative, a minus -2 is going to be positive. So you have the vertex of 2 and -6. So 2, -6 is going to be my vertex. Remember, the x value is going to be your axis of symmetry, so x equals 2. That means, you can split this right down the middle, where x equals 2. Do not pay attention to that dot. I just placed it in the wrong spot to begin with. The domain is all real numbers. The range is going to be y is going to be greater than or equal to everything, of everything above, or greater than -6. So I grabbed 2 numbers before the vertex, 2 numbers after in the x values, and you could see where those, once you plug those values in for x, or you plug it into Desmos, what the y values are, and you can go ahead and you can graph that. Now, I didn't talk about the transformations. Let me start with this one that I'm on right now. This is going to be down 6, right 2. The up and down is after the squared, so it's down 6, -6. And then if it's a minus value, if it's a minus h value, that's going to be moving to the right. If it's plus, if it's addition, that's going to be to the left. Okay? So this is minus, so that's right 2. And then once again, if you plug it into Desmos, you could see the parent function. Remember the parent function up here, the parent function is y equals x squared. That's it. So you can compare it. You could plug into Desmos y equals x squared. And then for your second equation, you could plug in this equation, y equals this value. And you could see, that, oh, yeah, it is x squared, but it is down 6 and to the right 2. The parent function would look like this, would look like that right there. And it's down 6 and to the right 2. If you just, take a look from your reference point, the vertex usually is a good reference point. The same with this one, number 1, a little bit more difficult because it was negative. You had like that negative x squared value. That's a reflection across the x-axis, meaning it flipped. Remember, the parent value would look like this, or the parent function, I should say. So it flipped, or a reflection across the x-axis, and then it's down 3. Down 3 is subtracted 3. Boom, boom, boom. Once again, you can look at that at Desmos. For number 5, I did put this one in Desmos because it was going to be off the charts and I wanted some numbers instead of just the next 2 numbers. Because I'm dealing with a fraction here, it didn't really work out to a nice clean number here. You could use your graphing calculators too. You don't have to use just Desmos. I keep talking about Desmos, but you could use your graphing calculators and plug that in. And then, go to the graph, and then you can, see the graph, and then you can see the table. If you click on the table, you can see these values here. The vertex. Okay, so the vertex is, it's positive 4 because remember it's a negative h. So negative, 2 negatives make a positive, so that's a positive 4. And we don't have anything back here. It's not moving, so it's going to be 0. It's going to stay on the x-axis, so it's not going up or down. It's going to stay right there. So your axis of symmetry is x equals 4 because 1, 2, 3, 4, it's right here. That splits it right down the middle. All real numbers is the domain. As always, the range is y is greater than or equal to 0. So everything greater than or equal to 0 on the y-axis would somehow satisfy this equation. It would find a place on this parabola somewhere. From the parent function, remember parent function is still y equals x squared. You can compare it on Desmos or on your graphing calculator, and you can take a look at it. This is right 4, so it went to the right 4, and it's a compression of 1/3, meaning it's a vertical compression. It's like opened up. It's compressing down on the x-axis by 1/3. Take a look at number 7. Without graphing, describe the transformations of the parent function. Once again, the parent function is y equals x squared. And you could plug this into your calculator, this one into your calculator, or Desmos, and you can compare that to the parent function y equals x squared. And you'll notice that this went to the right 2, and it went down 1. This one, this minus, says it's a reflection across the x-axis. And this is a compression of 1/2, like we have the compression of 1/3 here. It's going to be a compression, so it's going to compress down on the x-axis. And it's going to be left 1 because of the plus 1 there. Then we're supposed to write an equation to represent the function. So translated 1 unit right, that's going to be -1, and 5 units down, -5. Reflected over the x-axis, that's a minus, then vertically compressed by a factor of 1/4, so 1/4 x squared. Notice it didn't say it's going down or up at all, so there's nothing back here. Vertically stretched by a factor of 5/2, so we have 5/2, reflected over the x-axis, that's the minus, then translated 3 units down. So you have your x squared, and then it's -3. Notice it didn't say to the right or to the left, so I don't have anything with that x, like I had up here, that because it went to the right. I don't have anything going right or left. I just have it going down, so it's after the x squared that I have that -3. Okay, hopefully this is helpful, and good luck on the other ones.